Okay, so we continue with 6.1 by now talking about domains of a radical function. Let's not forget that our uh, simple radical function is just f of x equals the square root of x. And that when we take a look at this graphically, it starts here at the origin and starts going up. In order to find the domain, we set what's inside our radical. Here we call it the radicand. To be greater than or equal to 0, and you solve. Right? This will tell us all the value or values that cannot be in the domain. Example. Let's find the domain of the following. First one, let's say we have a function g of x, and we say g of x equals the square root of x plus 2. So once again, to find the domain, we set the radicand, and that's everything inside our square root symbol to be greater than or equal to 0 and solve. So here, we're going to set x plus 2 to be greater than or equal to 0 and solve. We subtract 2 to both sides. So you get x to be greater than or equal to negative 2. So what this tells us is that our domain, right, is set of x where x is greater than or equal to negative 2. Right? Or we can look at it in interval notation, and it is put brackets, right, because of this inequality symbol. All right, we say negative 2, comma, a positive infinity. All right, so two different ways of showing the domain to that example. How about one more example? Example B. Let's say that h of x equals the square root of 9 minus x. Once again, in order to find the domain, all we have to do is set our radicand, our 9 minus x, to be greater than or equal to 0, and we solve. Right, subtract 9, subtract 9. Right, so now you get negative, right, that's a 1x to be greater than or equal to negative 9. Then our next step would be to divide by negative 1, divide by negative 1. That cancels because we divide by negative, inequality symbol flips. So we get x to be less than or equal to 9. So our domain is a set of x where x is less than or equal to 9. And now we graph this one. This is saying x is less than or equal to 9. Let's not forget how it looks like on a number line. Here's 0, here's 9. So we go to the left, this time right. Put a bracket, so this would be negative infinity, comma, 9, close bracket. So some nice examples of finding the domain. Moving on in this section, what we can now also do, let's take a look at specifically finding the square root of a variable taken to the power of 2. So, what our principal root tells us, our theory tells us that the square root of a to the power of 2 is just the absolute value of a, right? So important to understand that principle, because from there we can go ahead and work some examples. Let's take a look here. Let's say we want to simplify our first example, the square root of negative 16 in parentheses to the power of 2. Well, if we follow our principle, it just tells us if we have something to the power of 2 inside our radical, all we got to do is do the absolute value of that. So this is just the absolute value of negative 16. You can see here we have the power of 2 and it is not there, right? So once again, if your radicand has a power of 2, you can just rewrite it as absolute value. Our radical has a radicand in the inside the power of 2, so you just write it as the absolute value of negative 16, and that just equals 16. How about our next example, B? This time we have the square root. How about open parentheses 3b, close parentheses to the power of 2? Same idea. Once again, we see that power of 2 inside our radical. So we could say the absolute value of 3b, ignoring that power of 2 now. Right? And this is just really the absolute value of 3 times the absolute value of b. And the only one that we can actually do is this one. So our answer here is 3 times the absolute value of b. Show some nice examples in regards of finding the square root of a to the power of 2. Once again, a is some kind of a number, but right now we're looking at it as a letter, uncertain of what that number is. Okay, and the last thing we'll look at here is finding cube roots, odd and even roots. So let's start with cube roots. Right, the notation. Now we see a little 3 inside our radical symbol, right? So be careful, the 3 goes in the inside. It is not 3 then that, because this symbol means square root. So it's important that the 3 is in the inside. This is a new term now. We can call this the root or the index. Okay, so it's not the 3 in the front, a big 3, it's a little 3 in there, okay? So let's take a look at some examples of simplifying. All right, now we have the third root of 8. All right, let's not forget what square root means, what number times what number. So this is what 3 numbers, right? So this answer here is 2, because 2 times 2 times 2 gives us 8. Example B. How about the third root of negative 27? Right, well, this answer here is negative 3. Once again, because negative 3 times a negative 3 times a negative 3 equals negative 27. Your calculator has a button on there. You just may have to look at it. It looks something like this on your calculator. Right, so I would suggest learning how to use that notation on your calculator. Okay, and let's do one more example. How about example C? The third root of negative 216 over 125. This answer here is negative 6 over 5. Once again, because negative 6 over 5 times negative 6 over 5 times a negative 6 over 5 gives us a negative 216 over 125. So these are some examples of cube roots. Let's take a look at some even and odd roots. So now we're going to see is that our index can be any potential even or odd number. All right, so let's simplify. How about the fifth root of 32? This answer is 2. Once again, 1, 2, 3, 4, 5 2's, right? 5 2's. If we multiply them, that gives us our radican. Example B, how about the fourth root of 16? Also an answer that gives us 2. This time we have 4 of them. 1, 2, 3, 4 gives us 16. Once again, nice examples where just learn how to use your calculator for some of them, right? Just learn how to use your calculator to check your work. And that concludes